Great. Thanks for all the artists. And right now we're going to have Jonathan talk about digital technology and 3D clay printing. And he's going to give us a brief history of 3D clay printing.
All right, thanks, Preston. So yeah, as Preston says, ceramic 3D printing. I think it's important to sort of state right from the outset that although we're talking about clay extrusion printing, there are other techniques in printing, and it's powder printing and slip sintering. Sorry, get this move on. So powder printing is actually probably one of the earliest sort of ceramic printing techniques. So it's come out of the plaster of Paris printing. So the Z Corps machine over here was a plaster machine that was then adapted to work in clay as well. Really expensive, high-end machines, but the great advantage of them is that the powder creates a support so you can do flat wear. And this is something that, the extrusion technique we use is very vertically orientated. It sort of builds up. Probably get a lot more detail out of a powder machine as well, but the machines are really not sort of studio-based machines. And I think, those who have been talking today are interested in actually participating with the machine rather than sending files to be printed somewhere else. So slip sintering, what's happening here, sorry, with a powder, the powder is laid down and then each layer is sort of where the positive shape is stiffened up, and then the negative powder is vacuumed away to create a form. With a slip sintering, a sort of liquid slip is put into the machine. Again, really expensive machines, this one coming from France, from Ceram, France. And then actually a laser beam moves around and it stiffens the clay where the positive shape is, and again the negative shape, the slip just runs away. But a sort of a cheaper version is the Formlab 2 machine that is here, that is actually normally a plastic machine using a polymer plastic. Well, a company in America, Teflon, have developed a porcelain type material, they call it porcellite, and that will print under the same conditions. So all these machines print very, very precisely, but there isn't a way that you can particularly get involved in the machine. Whereas I think the clay extrusion machine, one, it's more accessible, but it probably has a lot more option for artists, creatives, designers to actually get involved in the machines. This slide, I've sort of outlined three of the main providers of machines. This top one here, the American 3D Potter Bot, where each has kind of, interestingly, these developers have gone down different routes and their machines have different strengths. So this machine, the actual form that is being printed moves around underneath the clay extruder, and that is just slowly rising in the Z direction. So the XY moves. So you can end up with, you can handle a lot of clay in one of these machines and build quite thickly built objects, mainly because the print is moving around, and if it's very fine, it's going to sort of fall over or at least distort while printing. The Lutum-based Lutum machine, bottom left here from Netherlands, is a Cartesian setup, and that's an XY sort of box construction. So the print head is carried on this arm that sticks out. All of these machines work, perfectly well. They all do, what the artist wants. And you just have to decide where your strengths are. And the Cartesian system is actually a lot better for doing horizontal work. It's got a greater sort of stretch across from front to back, left to right, sort of thing. Wasp from Italy, I put them at the top there, have gone down the route of a Delta type printer where the movement is controlled by these Delta arms and is a very smooth kind of movement, but you have to have a very tall rig to go out horizontally. So other producers of machines in Estonia, coming from China more recently, and coming out of Poland. Trying to put a bit of history to this. The principle of what we're doing, extrusion 3D printing, is ultimately computer-guided coil building. So it's developed out of one of the oldest ways of making form out of clay, and that is rolling out a clay a snake of clay and slowly building it up into a three-dimensional object. So David Harrod, back in 2001, built this machine that is a kind of halfway point between something that's pretty analog and has what has developed into the printer. So on the right hand here, there's a hand ram that is squishing the clay down that will then go along the pipe and then slowly build up as a layer on the form here. And this turntable would be moved one movement at a time, so on and so forth. I mean, it is digitally controlled over here. So a precursor to this, to where we've got to now, I guess, was the RepRap machine. So there's this image over here that, I forget the developer's name, Adrian Bauer, sorry. So 2000, I've got it at the bottom, 2007, Professor Adrian Bauer, working at Bath University, was a precursor to the idea of a self-replicating machine. These were made in plastic, for plastic printing, but 2007 was actually before, obviously, the economic crash of 2008, and that was kind of a historical moment in time for the whole sort of 3D printing and particularly sort of fab lab development. It was post 2007. So it's actually quite difficult to put yourself back in time to this point. Personally, I'd become interested. I'd been working on computers to explore 3D forms for some time. So I'd actually written to Adrian Bauer asking whether it would be possible to use one of these sort of rather DIY machines to print in clay. But he didn't pick up on it, and I didn't particularly at the time. I had other work that I continued with. So the kind of real breakthrough was, well, 2010, a design duo, Unfold, who are based in Antwerp in Belgium. By then, this machine was being sold through a little startup company down in the southwest in the UK. They bought one of these kit machines that was, at that stage under £1,000, where a powder printer was, £50,000. But we were getting to a point that you could then have a printer that would be in your studio. And this image on the right is actually, once I saw Unfold doing it, I contacted them, I went and I copied this. And it literally was the plastic printer, and we wouldn't build the plastic printed, we would put on a syringe and then pressurize that syringe with an air compressor that would squirt the clay out, and the rig would then move around and coil build in the correct position. So from there, going on to more kind of DIY systems, after a couple of years, the machine that we were getting from the West Country was, the production was stopped. So in 2013, I built my own Delta machine. By then there was enough information online that I sort of felt I could do this. I didn't have to know what was going on in the box. All that information was online. I mean, it's a matter of standing on other people's shoulders to put it all together. There were plastic machines looking like this that printed in plastic. But what I did was to find a sort of a glue gun solution to the clay container. Again, this was then compressed air was pushing it out. And, this has then developed into, a lot more machines. Tom Lauman, who I've had a lot of conversation with, building a machine in 2018, actually similar to the American Potterbot one, where the base actually moves and the clay container just moves up and down in the Z. But, what I guess I'm trying to say here is that it became accessible to this, the person wanting to work in their own studio and not send files off to be done, to be printed by somebody else. So this slide here is representing, in some ways, the best way to go now is, rather than buy all the parts and try and build the machine yourself, is to buy a ready-made plastic machine. So there's the plastic print head there that you wouldn't use, and then substitute that with a clay printhead. So this printer coming from China in a flat pack, unfortunately this exact article isn't available any longer, but is £150. The clay printhead adaptation at the back that, you know, I'm afraid is me making it myself, I can reduce it down to £150. So for sort of £300, you've got a DIY printer you can get on with. So far, I've really spoken about, obviously, the printing machines, but I always point out to people when they see printers running, it's about working on computer. If you're not interested in computers, then probably 3D printing is not for you, because firstly, you have to get a form to produce a file from to give to the printer to print. It is in my nature that I kind of want to do everything on the cheap. And so all of these softwares here are free to use. A really good sort of starting one being Tinkercad. And I really like this. You have to sign up for it, but it's an online, easily accessible and usable 3D modeling program. SculptFab, again, an online program, nothing to be downloaded. You can start building a shape very quickly. My main 3D drawing program, known as CAD program, I guess, is something called Blender. That is an open source program coming out of Holland that is just incredible. You know, I can't say enough about it, and mainly because of the ethos that it is open source. You will need to, and those people who work in the system know that you know, you will produce files in some sort of modeling program, and then there is another piece of software that's required to produce a file that the printer understands, and that we term the slicing program. Cura is a free-to-use option, and there are others. This just happens to be the one I use. Necessary, it's the one I've learned to use, and that's why, you get to know one piece of software, but there's probably better ones that I just don't use. And you can see how the gray is the actual form that is being processed, and then this program slices through, and it's giving you an indication of what a virtual kind of visualization of the running machine will be. So kind of going forward a little bit is, I think modeling in augmented reality hasn't caught on, or this photograph was taken a couple of years ago, because often the actual modeling part seems to be a bit of a blockage for creatives to get involved in, that they don't want to spend the time, and it's a lot of time, to often learn a CAD program. Modeling with augmented reality may well be a way forward with that. Uses ceramic printing, medical, and using very high-end machines, as in the slip sintering and powder printing very often, bone replacement, dentistry, engineering similarly. For the industry, 3D printing is not really caught on, because traditional techniques or molding and so on and so forth can outperform. Ultimately, 3D printing is quite slow in comparison. So, possibility of luxury goods, very few dining, pieces for dining coming out of 3D printing. I think the break point will be when a piece needs to be customized individually for the customer, because that's the strength of 3D printing, that each time it gets printed, it may as well be a different shape. If you're reproducing the same shape over and over again, you may as well use, other techniques than 3D printing. So it's kind of architectural and artistic that has been probably the main drivers within the more creative sort of development of ceramic 3D printing. Architecture in particularly, this is the Wasp group out in Italy, that although they produce 3D printers, the production of their printers is almost to finance their research work that is going on the whole time. Their desire is to be able to build relief housing with 3D printers. So that's what's going on here, is trying to develop a way of doing that, and some examples coming out of China of architectural schools. On the whole, it's using a modular system. That scale becomes a problem with, architectural scale, with getting it into a kiln, because we're working with ceramic. It's either unfired, or if you want to fire, it's got to go into kiln. And these are solutions. And the strengths being, working in a modular manner, is that each module can be very much customized to, the requirement and different. Returning to Wasp again, on the left-hand side, we can see, sorry, I returned to Wasp is because this is the experience I've had. I've visited them and worked with them. Was the very large printer on the left-hand side. Then the next phase on with it, they had problems with this large printer. And what is quite interesting here was that it wasn't necessarily a technical problem with the engineering of the printer. It was a material problem. That is interesting that if you tend to think of 3D printing, you're talking tech and, oh gosh, and there is lots of tech. I don't want to underplay that. But what they found is the amount of material that they had to deal with, literally tons of clay when you want to work on this scale. And then also it doesn't dry very quickly, even in an Italian summer. The solution was that this so-called crane printer that they have, so it's a rig with a crane that sticks out, and the print nozzle hangs off of the crane here, is a much simpler solution to that. So, kind of the eco credentials, you can see the clay pit is literally, the material has been dug, wheelbarrowed around, put in the mixer. From the mixer, it gets put into the clay pump, and the clay pump drives it into the print head. And, because this has been driven digitally and coming from a digital file, they can then create the wall. The idea here is that the architecture is unfired, it's Adobe type clay. And as long as you keep a good roof over it, as proven down in the West Country in the UK, Adobe will literally last for ages. So far I've spoken about printers mainly for 3D printing, but ultimately all you have is some sort of rig that will move in three-dimensional space and deposit the clay in the correct place. I guess that's some sort of definition towards what a printer is. So a robot arm will do that perfectly well. And there was a period I sort of personally got really excited with robots, but once I met up with them, I realized the amount of kind of control and the knowledge that is needed to actually run a robot is beyond, kind of, I tend to think in studio ways rather than big workshop manners. But the 6 axes that a robot can offer are probably more than are required for just standard 3D printing. That's not to say there isn't a lot of work to be done in robots, and it's a really interesting area. But I think there's a lot to be said for the basic, sort of, ultimately a 3D printer is a 2-dimensional rig that builds up in the 3rd dimension, in the Z direction, in the vertical direction. So it's a number of 2-dimensional cross sections that then get piled up. So just some little bit of history. I mean, this has been going 10 years, obviously. Sorry, I say obviously, but this is Unfold. So Dries van Bruggen, Claire isn't in the picture, but the partnership of Unfold, who started the extrusion printing 10 years ago. This was their first project that they used, their virtual pottery machine. And you can see that early machine that I was talking about. Some work of theirs in porcelain. So 2010. Other earlier people who took it up, developers of the, call it the craft, the art form, the process, the technique, it's all of those things. Oliver van Happen from the Netherlands, 2014. Again, at that stage, you couldn't buy a machine, you had to build your own machines, and this was his machine. That didn't use air. I think a lot of the machines I've shown you so far, the clay gets rammed out, gets pushed out under air compression. This one actually had a mechanical ram that would press it out. That, is another option. Flemming Hanson, working in Denmark, actually did his PhD in 2007 around digital clay. So again, somebody who sort of isn't necessarily very well known within ceramic 3D printing, but has been working in the field for a long time. Early on was using powder printing machines, and now has gone on to working with robot arms and extrusion printing. And quite interesting in this work, it's got a very three-dimensional aspect to it, or not so layered as is so typical of 3D printing, because he actually scans the base that he prints onto first, and then the robot arm, the information can be given to the robot arm such that there's a kind of landscaped quality to these pieces, rather than the very kind of horizontal feel that is common in a lot of 3D printed work. Brian Seabaz in America, not the only early uptaker of the technique, but somebody I like to highlight because of the range of work that he's done. This was actually collaborating with somebody who can throw, who makes pots thrown. I'm sure Brian can probably throw as well. So this is a combination of thrown sections of ceramic as well as 3D printed ceramics. Some other pieces of Brian, and this is a bit what Nico was talking about, is actually kind of really pushing the process and the technique. So in this case, the nozzle isn't sort of settled right down on the layer underneath it. So as it builds up, you get much more of this sort of spaghetti quality. So the form is there, still there. It's almost the kind of using the accident. Somebody who's recognized in the fine art world, Anya Galachio, using the same sort of visual vocabulary, I guess talking about industrial development, deterioration, but as an installation in galleries where she's, I guess, not that interested in the 3D printer as much as the process and the communication, the artistic expression of the piece. And then in the US, Emerging Objects, that is again, architectural design duo of Virginia Sanfratelli and Ronald Ray, have been working in 3D printing in many media. And from, I should think about 2015 onwards, have included a lot of clay in their work, as in these pieces. And a final couple of slides here, Joanna Schmidt working in Germany. I like to include these in talks, these images in talks, in that she's been felt very strongly to try and make objects that are usable. And this isn't for everybody. I'm very interested in more sculptural objects, but Joanna wants to work. And how she's actually used her knowledge of 3D printing incorporated in the design of the pieces. So here, the texture that one can create with a knowledge of, how the whole system works becomes the greater for the garlic. And then in this lemon squeezer, there's a sort of sieve underneath here, you can see that. And that's knowing how the slicer program works, so that, the slicer normally, it can be set up to make a base. She's made enough space in the base such that it becomes a sieve. So I think these are really interesting situations of where really understanding the kind of the craft of the printer, understanding her material, understanding the process, gets worked back into the design. That there's no plug and play going on here. She's not producing a CAD file and sending it off to somebody else to actually execute. It's her knowledge of the whole process that goes into it. And then I'm afraid I put some pieces of mine in the end here, some teapots. And it's really just to illustrate how here, normally a teapot would be made in sections and then put together. But I've kind of thought through how the print head moves. And you can see that the holes where the tea will go into the teapot spout are being printed. The handle has been printed. And the whole thing is completed in one go with the lid in place. And then I can just cut that away and drops down into the teapot, into a completed teapot. So all these files are available on Thingiverse, and this project here I just think there are probably a lot of 3D printers sitting out there that the owners are looking for, objects to print. And I think sharing of files is a possible way forward for this. And if you want to make yourself a teapot, the file is on Thingiverse. So thank you very much.
Jonathan, that was great. It was a really wonderful overview of the history of 3D clay printing in such a short period of time, how it advanced rapidly with development